For this next example, we're going to first need to do a u substitution. Then we'll be able to go to the table. And there's actually a couple ways that you can approach this example here, but I'll get there in just a moment. Let me start with the u substitution. So we're asked to integrate the inverse sine of the square root of x dx. I'm going to let u equal the square root of x. Oops. So then if I differentiate, I have du equals 1 over 2 times the square root of x dx. Solving this for dx, I have 2 times the square root of x du equals dx. But if u equals the square root of x, I can rewrite this as 2u du equals dx. Armed with this information, I'm going to go back up here and rewrite it. So now I've got inverse sine of u, and dx is equal to 2u du. Now, I do want to point out something here. If you look at the table at number 106, it actually matches what we have. X to the n, so in this case it's a u to the first power, so that n would be 1. Inverse sine of ax, so the a is also 1. So we have a very we have a formula that we can plug into. I was going to say straightforward, but it's not. You can also get to this formula by using the product rule for integration. In my written notes, I have done it that second way, using the product rule, where we use that to come to this formula. But I'm going to do this example here just to show you that it can be done in more than one way. I'm going to use this formula 106. It's going to actually lead us to use a second formula, so sometimes that can happen, but I'm getting ahead of myself a little bit. So what I have here, and I'm going to rewrite this to let it match that number 106. I'm going to bring the 2 in front. So I've got u times inverse sine of u du. So like I said, we're using number 106. Our n value is 1, and the a is also going to be 1. So now I'm going to plug into what we have here with this formula. Keep in mind that we've got a 2 in front of the whole thing. So it's x to the n plus 1. So in our case, it's going to be u to the second power over n plus 1, that's going to be 2 as well, times the inverse sine of ax, well in our case it's au, so 1 times u is u. So that's the first part done. Then we have minus a over n plus 1, so that's going to be 1/2. And then we're going to have to integrate x to the n plus 1, so that's going to be, in our case, u squared du over the square root of 1 minus a squared, which is also a 1, u squared. So 1 minus u squared. That 2 that we had in front is going to get rid of the 2's in these two denominators. So I have u squared inverse sine of u minus, and we're going to integrate u squared du over the square root of 1 minus u squared. So we're going to go back to the formula table. We're going to do this process one more time. So with this here on the right, if you go over here, it's going to be number 49. There we go. So these are forms involving a squared minus x squared. 49, there's our formula. So again, we've got u instead of an x, and in our case, the a is going to be 1. So we're using number 49 with a equals 1. So I've got my u squared inverse sine of u. Then from all this, don't forget that minus in front. So going over here to number 49, I've got a squared over 2. So 1 squared over 2, it's a 1/2. Inverse sine, and it's going to be u over 1 in our case. So that's just going to be a u. Then minus 1/2 times u times the square root of a squared, so that's going to be 1 minus u squared, and then the whole thing plus c. Oh, I can put that here. So if I get rid of the brackets, it's going to take this negative and distribute it, which gives me u squared inverse sine of u minus 1/2 times the inverse sine of u plus 1/2 times u times the square root of 1 minus u squared plus c. Almost done. We are nearly finished. Because we did the substitution at the beginning where u equals the square root of x, we need to go back and take care of that. So any place I see a u, I want to replace it with the square root of x. So u squared is the square root of x squared, so that's just going to be x. Inverse sine of the square root of x minus 1/2 inverse sine of the square root of x. And if you wanted to, you could combine these two terms. In my written notes, I went ahead and did one last step where I combined these two terms, but you don't absolutely have to. Then here I've got plus 1/2 times the square root of x. And then I've got another radical where it's going to be 1 minus x, and then the whole thing plus c. So like I mentioned before, you don't have to combine these first two terms, but if you want to, you can. And I mentioned I did that in my written notes. Because I'm going to take one extra step to clean this third term, I want to clean this up a little bit. I'll go ahead and do that for you as well. So you'd have x minus 1/2 times inverse sine of the square root of x. And then here, the square root of x, since it's under a radical, I can multiply. So we end up with the square root of x minus x squared plus c. And so in this case, we end up using that table twice before getting the answer. Like I mentioned earlier, you could have done the product rule for integration, which would take you to the exact same answer. And if you're interested in seeing that, it is in my written notes.